I want to play through one more of this special kind of limit, and you'll see how this kind of dovetails and flows together with some of the work we've done already in this section, and being able to compute these limits. So again, here's the function. We want to compute the limit of, that's called the difference quotient. So you start with the generic expression. Start with the generic expression, f of x plus delta x. Try that again. F of x plus delta x minus f of x all over delta x. What's that equal to? So that's equal to this limit. So substitute this expression in for that variable. So this should start to look familiar. X plus delta x plus 3. There's this first piece. Minus, in parenthesis, the second piece. There's the second piece. All over delta x. Now, distribute this a little bit. This is the square root of x plus delta x plus 3 minus the square root of x minus 3. The 3's cancel, and what are we left with? Square root x plus delta x minus square root of x all over delta x. Direct substitution gives us 0 divided by 0. This should look familiar. This is a binomial with radicals. This is a candidate for our knowledge, our understanding of the conjugate technique, the technique of multiplying numerator and denominator by the conjugate. And so this is equal to the limit x plus delta x minus square root of x. We need to multiply by conjugate over itself. Conjugate over itself. The conjugate is, put a plus sign here, x plus delta x plus x, square root x plus delta x plus x. Remember our technique, now it's a straightforward technique from before. See, our accordion is expanding out here. This is the limit. Delta x goes to 0. Now, this is not quite the same because this is not a polynomial like the previous examples. So what happens here is when you multiply these conjugates, you get the first one squared. So square the first minus square the last. Oh, this is a square root. Typo. That was a typo. This needs to be square root, square root, square root, square root. Make sure. This is radical x plus delta x minus radical x. This is radical x plus delta x plus delta x. All right? So it's the first one squared, is what we have here, minus, it needs to be minus, last one squared is just x, all over delta x, and then we have square root x plus delta x plus square root of x. All right? So far, so good. Just trust the procedure. Trust the procedure. Multiply by the conjugates. Follow the algebra trail wherever it leads. These x's cancel. And then, let's go write it out one time. The only thing left in the numerator is delta x. This is delta x times and so since this is multiply, you may cancel with multiply. You may not cancel with addition. You may cancel with multiply, so that reduces out. Remember, if everything goes from the numerator, you leave a 1. And so we're left with the limit 1 over. So no matter what else happens, we're not going to get 0 divided by 0 because in the numerator we got 1. And so this is x plus delta x plus square root of x. All right? Remember, delta x is going to 0, not x. Delta x is going to 0. So this piece goes to 0. This is a constant. With respect to this limit, x is a constant. And And the limit of a constant is the constant. So this is simply 1 over, it's the square root of x plus the square root of x. And you could leave it like that, or you could simplify this. A plus a is 2a, thing plus thing is 2 thing. So radical x plus radical x is 2 radical x, and the trick is done. So this combines this new limit of or difference quotient with our old knowledge of how to multiply by the conjugate. So it's dovetailing the work that we've done in the various 2 sections here.